Great. So I'll get started. If you've used Reddit before, you've probably seen this a few times. I'm hoping that you'll see it less and less, but you've definitely seen it. This talk will hopefully help you understand why. If you've not used Reddit, then how about a quick explanation? Reddit's the front page of the internet. It's a community hub, and it's a place for people to talk about everything that they are interested in. But more importantly, for this topic, Reddit is a really big website. We're currently the fourth largest in the US according to Alexa and serve 320 million users every month with doing all sorts of stuff like posting 1 million times a day and casting 75 million votes. It kind of adds up. So let's dig into what the site looks like. This is kind of a very high-level overview of the architecture of Reddit, and it's focused only on the parts of the site that are involved with the main core experience of the site. So I'm leaving out some really interesting stuff like all of our data analysis and the ad stack, all that kind of stuff. But this is the kind of core of the Reddit experience. The other thing to know about this diagram is that it's very much a work in progress. I made a diagram like this a year ago, and it looked nothing like this. This also tells you a whole lot about our engineering organization as much as it tells you about the tech that we use. So that's actually really interesting here. In the middle there, that giant blob is R2. That is the original monolithic application that is Reddit and has been Reddit since around 2008. That's a big Python blob, and we'll talk about that in a bit more detail. The front-end engineers at Reddit got kind of tired with the pretty outdated stuff that we have in R2, so they've been building out these modern front-end applications. Those are all in Node, and they share code between the server and the client. They all act as an API client themselves, so they'll talk to APIs that are provided by our API gateway or R2 itself, and act just like your mobile phone or whatever other API clients out there. We're also starting to split up R2 into various backend services, and these are all highlighted here. The core thing here is that they are kind of the focus of individual teams. So you can imagine that there's an API team, there's a listing team, there's a thing team. I'll explain a little bit more what those mean later. They are written in Python, which has helped us splitting stuff out of the existing Python monolith, and they are all built on a common library that allows us to not reinvent the wheel every time that we do this. It also comes with some monitoring and tracing, that kind of stuff built in. On the back end, we use Thrift, which gives us nice, strong schemas, and we allow also for HTTP on the front end for like the API gateway so that we can still talk to them from the outside. Finally, we have the CDN in the front. That's Fastly. And if you saw the talk earlier, they do some pretty cool stuff. One of the things we use it for is being able to do a lot of decision logic outside at the edge and figure out which stack we're going to send that request to based on the domain that's coming in, the path on the site, any of the cookies that the user have, including perhaps experiment bucketing. So that's how we can have all of these multiple stacks that we're starting to split out and still have one reddit.com. So since R2 is that big blob and it's really complicated and old, let's dig in a little bit more into its details. The giant monolith here is a very complicated beast that has its own weird diagram. We run the same code on every one of the servers here. It's monolithic. Each server might run different parts of that code, but the same stuff is deployed everywhere. The load balancers in the front, we use HAProxy. The point of that is to take in the request that the user has and split it up into various pools of application servers. We do that to isolate different kinds of request paths so that, say, a comments page is going slow today because of something going on, it doesn't affect the front page for other people. That's been very useful for us for gating these kinds of weird issues that happen. We also do a lot of expensive operations when a user does things like vote or submit a link, etc. And we defer that to an asynchronous job queue via RabbitMQ. And so we put the message in the queue and processors handle it later, usually pretty quickly. These Memcache and Postgres section, we have a core data model, which I'll talk a bit about, called Thing. And that data model is what you would consider most of the guts of Reddit: accounts, links, subreddits, comments. So all of that stuff is stored in this data model called Thing, which is based in Postgres with Memcache in front of it. And finally, we use Cassandra very heavily. It has been in the stack for about 7 years now and has been used for a lot of the new features ever since it came on board, and has been very nice for its ability to stay up with one node going down, that kind of thing. Cool, so that was a bit about the structure of the site itself. Let's talk about how some of the parts of the site work, starting with listings. So a listing is kind of the foundation of Reddit. It's a list, an ordered list of links. You could naively think of this as just selecting links out of the database with a sort. These you'll see as the front page, you'll see it in subreddits, etc. The way that we do it is not actually by running the select out of the database. Instead, initially, what would happen is the select would happen, and then it would be cached as a list of IDs in Memcache. That way, you can fetch that list of IDs very easily, and then you can just look up the links by primary key, and that's very easy as well. So that was a nice system and worked great. Those listings needed to be invalidated whenever you change something in them, which happens when you submit something, but most frequently it happens when you vote on something. And so the vote queues are something that really update those listings very frequently. We also have to do some other stuff in those vote processors, such as anti-cheat processing. So it turns out that running that select query, even occasionally when you invalidate it, is still kind of expensive. So when you're doing something like voting, you have all the information you need to be able to go and update that cached listing. You don't really need to rerun the query. So what we do instead is we store not just the ID, but the ID paired with all of the sort information related to that thing. And then when we do something like process a vote, we fetch down the current cached listing, we modify it. In this example, you'll see that we vote up on link 125, which moves it up in that list and changes the score that it has in that list. And then we'll write it back. That is kind of an interesting read, mutate, write operation, which has the potential for race conditions. So we lock around that. And you'll notice that once we're doing that, we're never actually running these queries anymore. It's not really a cache anymore. It's actually its own like first-class thing that we're storing. It's a persisted index, really, a denormalized index. So at that point, they started being stored, originally in other things, but nowadays in Cassandra. So I'm going to talk a little bit about something that went wrong. I mentioned that sometimes the queues usually process pretty quickly. Well, not always. Back in around middle of 2012, we started seeing that the vote queues would start getting really backed up in the middle of the day, particularly peak traffic when everybody's around. This would delay the processing of those votes, which is visible to users on the site because a submission would not get its score properly. It would be sitting on the front page, but its score is going up very slowly, and it really should be much higher than it is, and then it would finally get it many hours later when that queue processed. Well, one easy thing is, why don't we just add more processors, right? That actually made it worse. So we had to dig in. We didn't really have great observability at the time. We couldn't figure out what was going on. We could see that the whole processing time for a vote was longer than before, but beyond that, who knows? So we started adding a bunch of timers. And once we narrowed it down, we found out that it was those locks I mentioned that were causing the problems. The very popular subreddits on the site are getting a lot of votes. It makes sense. They're popular, right? So when you have a bunch of these votes happening at the same time, you're trying to update the same listing from a bunch of votes at the same time, and they're all just waiting on the lock. So adding more just added more people waiting on the lock and didn't actually help at all. So what we did to fix this was we partitioned the vote queues. So this is really just dead simple. We took the subreddit ID of the link being voted on and used that and just did like modulo 10 and put it into one of 10 different queues. This just looked like, you're voting on a link that's in subreddit 111 or 111. You go into vote queue 1. Vote 777, go into vote queue 7. And what that did is we had the same total number of processors in the end, but they were all divided up into different partitions, and there were far fewer vying for the same lock at any given time. This worked really well. Smooth sailing forever. Not really. So late 2012, just a few months of respite, we started seeing the vote queues slowing down again. The lock contention time was okay in the average, and the processing times looked okay in the average. But then we looked at the P99s, the 99th percentile of those timers, and we were seeing that there were some votes that were going really poorly, and that was interesting. So we had to dig in and just start putting print statements in to see what is going on when you're taking over this amount of time. It's pretty dumb, but it worked. And what we found was that there was a domain listing. So we have listings on the site that are for all of the links that are submitted to a given domain. Oh, sorry. Dangers of a touchscreen. The domain listing was the point of contention now. So all of these things were partitioned and not vying for the same lock for subreddits, but they were then in the same thing vying for a domain listing. This was not great, and it was causing a lot of issues. So long story short, much later, we comprehensively fixed this by splitting up those queries altogether. Instead of just processing one vote in an entire single job processor, we now do a little bit of upfront stuff and then make a bunch of messages that deal with different parts of the job. And those all work on the right partitions for themselves, so they're not vying across partitions. Interesting stuff here is that you really need to have timers in your code, nice granular timers, but they also just give you a cross-section. You get a lot of info from your P99s, and tracing or some way of getting info out of those P99 cases is really important as well for figuring out what's going on in the weird cases. There's also kind of obvious, but locks are really bad news for throughput. If you have to use them, then you should probably be partitioning on the right thing. And so going forward, we've got some new data models that we're trying out for storing those cache queries in a lockless way. It's pretty interesting, and it's been promising so far, but we haven't committed fully to it yet. And more importantly, we're starting to split out listings altogether. So we've got this listing service, and the goal of it, and we have a whole team working on it, is to make relevant listings for users. And the relevant listings can come from all sorts of sources, which includes the data analysis pipeline, machine learning, and these normal old listings like the rest of the site. So that's kind of the future here, where we extract it out into its own service, and R2 doesn't even need to know about how it's coming anymore. Cool, so you got listings of things, but what about the things themselves? As I said earlier, the thing is in Postgres and cache. This is the oldest data model in Reddit in R2, and it's a pretty interesting data model. Getting some smiles. The thing to know about it is that it was designed to take away certain pain points, but also make it so that you couldn't accidentally do something like expensive joins. It's vaguely schemaless, and it's very key value. There's one thing type per noun on the site, so like an account thing, a link thing, a subreddit thing. And each one of those is represented by a pair of tables in Postgres. The thing table looks like this. It's a little bit abbreviated, but the idea is that there's one row for each thing object that exists. And there's a set of fixed columns there, which covered everything that the original days Reddit needed to do the just basic select queries to run the site. So that's all the stuff that you would sort and filter on to make a listing back in the day. The data table, however, has many rows per thing object, and they each have a key and a value, and this makes up kind of a bag of properties for that thing. This has been pretty neat for Reddit in terms of the ability to make changes, make new additions to the site without having to go and alter a table in production. It's very, very cool in that way. It's also been a lot of performance issues, so it's interesting. Thing in Postgres is done as these set of tables live in a single database cluster. Each primary in that database cluster handles writes, and then we have a number of read-only replicas which we replicate to asynchronously. R2 connects directly to the databases, and we'll try to prefer to use the replicas for read operations so that they scale out better. At the time, it would also do this thing where it determines that if a query failed, it would guess that the server is down and try to not use it again in the future. Thing also works with memcache. This helps us reduce the load on those read replicas. The whole thing object is serialized and it's popped into memcache. R2 reads from memcache first and only hits Postgres on a miss. And we write directly to memcache from R2 when making the change, rather than just deleting from memcache and allowing it to be repopulated on the next read. So a way that this broke. 2011, we were waking up a lot with these errors. We would wake up suddenly with an alert saying that the replication to one of the secondaries had crashed. And this meant that that database was getting more and more out of date as time went on, so obviously we need to fix that. The immediate thing to do is you just take that thing out of replication and out of usage on the site, and you start rebuilding it and go back to bed. But then we started seeing the next day when we woke up that some of those cached listings were referring to items that didn't exist in Postgres, which is a little terrifying. So you'll see this cache listing here says 1, 2, 3, 4, but then the thing table only has 1, 2, and 4. Not a great thing to see. This caused the pages that needed that to crash because they were looking for the data and it wasn't there and they just died. So we built out a lot of tooling at the time to be able to clean up those listings, find any bad data that shouldn't be there, and remove it from them. This was obviously really painful, so we were looking into a lot of things going on there. There weren't a whole lot of us either. It was about 5 people at the time. The issue we found always started with a primary saturating its disks, so it was running out of IOPS and something was going slow. So what did we do about that? We just got beefier hardware. It's pretty good, right? Problem solved. Not really. So a few months later, everything had been nice and quiet for a while, but we were doing a pretty routine maintenance and accidentally bumped offline the primary. And suddenly we see the replication lag alert firing. And looking at the logs from the application at the time, a light bulb went off. So I mentioned that R2 would try and remove a dead database from its connection pools. The code for that looks something like this, very pseudocodey. We have in configuration a list of databases, and we consider the first database in the list to be the primary. So then when we're going to decide which database to use for a query, we take the list of databases, we filter it down to the ones that are alive, we take the first one off the list as our primary, and the secondaries are the rest. Then we choose based on the query type which server to use and go for it. There's a bug there. So what happens when it thinks the primary is down? It would instead take the primary out of the list, and now we're using a secondary as that first item in the list, and we try writing to a secondary. Well, we didn't have proper permissions set up, so that worked, and you could write to the secondary. Oops. So you wrote to the secondary, it created the thing, and we write it to the cached listing. All is good. Then we take that secondary out and rebuild it, and that data's gone. Not good. So yeah, use permissions. They're really useful. They're not just there to annoy people. They're very helpful. If you do denormalize like the cache listings, it's really important to have tooling for healing. And going forward, some changes we're making. New services are using our service discovery system, which is pretty standard across all our stack, to find databases. So they don't have to implement all this logic in themselves. And that helps with reducing complexity, making it a battle-tested component. And also, finally, we're starting to move that whole thing model out into its own service. The initial reason for this was we had new other services coming online, and they wanted to know about the core data that's in Reddit. So we had this service that starts out by just being able to read that data, and now it's starting to take over the writes as well and take that all out of R2. A huge upside to this is that all of that code in R2 had a lot of legacy and a lot of weird twisted ways that it had been used. And so by pulling it out and doing this exercise, it's now going to be separate and clean and something that we can completely rethink as necessary. Cool. So another major thing. I said that Reddit is a place for people to talk about stuff, right? Well, they do that in comment trees. So an important thing to know about comments on Reddit is that they're threaded. This means that you nest replies so you can see the structure of a conversation. They can also be linked to deep within that structure. This makes it a bit more complicated to render these trees. It's pretty expensive to go and say, okay, there's 10,000 comments in this thread. I need to look up all 10,000 comments, find out what their parents are, etc. So we store, hey, another denormalized listing, the parent relationships of that whole tree in one place so that we can figure out ahead of time, okay, this is the subset of comments we're going to show right now, and then only look up those comments. This also is kind of expensive to do, so we defer it to offline job processing. One advantage in the comment tree stuff is that we can batch up messages and mutate those trees in one big batch. That allows for more efficient operations on them. An important thing to note is that the tree structure is sensitive to ordering. So if I insert a comment and its parent doesn't exist, that's kind of weird in a tree structure, right? So that needs to be watched out for because things happen. And the system had some stuff to try and heal itself in that situation where it will recompute the tree or try to fix up the tree. The processing for that also has the issue that sometimes you end up with a mega thread on the site. Some news event is happening, the Super Bowl is happening, whatever. People like to comment. You have 50,000 comments in one thread, and that thread is now going pretty slowly. That's affecting the rest of the site. So we developed a thing that allows us to manually mark a thread and say, this thread gets dedicated processing. It just goes off onto its own queue called the fast lane. Well, that caused issues. Early 2016, there was a major news event happening, pretty sad stuff, and a lot of people were talking about it. The thread was making the processing of comments pretty slow on the site, and so we fast-laned it. And then everything died. Basically what happened immediately then was the Fastlane queue started filling up with messages very, 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 very quickly. and rapidly filled up all of the memory on the message broker. This meant we couldn't add any new messages anymore, which is not great. In the end, the only thing we could do was restart the message broker and lose all those messages to get back to steady state. So this meant that all of the other actions on the site that are deferred to queues were also messed up. What it turned out to be the cause was that stuff for dealing with a missing parent. So when we fastlaned the thread, the earlier comments in the thread that had happened before the fastlaning were still in the other queue, and they were still not yet processed. And when we fastlaned, we suddenly skipped the queue with a bunch of new messages. So then the site recognized that this thread was inconsistent, and every page view was putting in a new message onto the queue saying, hey, please recompute me, I'm broken. No, not good. So yeah, as I mentioned, we restarted Rabbit. Everything kind of went back to normal afterwards, and we now use queue code quotas, which are very, very nice. Resource limits allow you to prevent one thing from hogging all of your resources. So it's really important to use things like quotas. If we had turned on quotas at the time, then that fastlane queue would have started dropping messages, and it would have meant that that thread might have been more inconsistent, or comments wouldn't show up there for a little while, but the rest of the site would have kept working. Cool. All right, so this is a little more meta. We have a bunch of servers to power all of this stuff, and we need to scale them up and down. So this is kind of what traffic to Reddit looks like over the course of a week. It's definitely very seasonal. So you can see that it's about half at night at what it is in the day. There's a couple weird humps there for different time zones, but it's pretty consistent overall. And so what we want to do with the autoscaler is save money off peak and also deal with situations where we need to scale up because something crazy is going on. It does a pretty good job of that. What it does is it watches the utilization metrics reported by our load balancers, and it automatically increases or decreases the number of servers that we're requesting from AWS. We just offload the actual logic of terminating or launching servers to AWS autoscaling groups. That works out pretty well. The way that the autoscaler knows what's going on out there is that each host has a daemon on it that registers its existence into a Zookeeper cluster. This is kind of a rudimentary health check. And of note is that we were also using this system for Memcache. It is not really autoscaled in that we were ever going up or down, but it was there so that if a server died, it would be replaced automatically. So in mid-2016, something went pretty wrong with the autoscaler that taught us a lot. We were in the midst of making our final migration from EC2 Classic into VPC. This had a huge number of benefits for us in better networking and security, that kind of stuff. And the final component to move was our Zookeeper cluster. This was the Zookeeper cluster being used for the autoscaler, so it was pretty important. The plan for this migration was to launch the new cluster into VPC, stop the autoscaler services so that they don't mess with anything during this migration, repoint the autoscaler agents on each of the servers out in the fleet to point at the new Zookeeper cluster that's in VPC. Then we'll repoint the autoscaler services themselves at the new cluster, restart the autoscaler, and then act like nothing ever happened. What actually happened was a little different, unfortunately. We launched the new Zookeeper cluster. It's working great. We stop the autoscaler services. Cool. We start repointing things. We got about a third of the way through that when suddenly about a third of our servers get terminated. And it took us a moment to realize why. And then we all face-palmed rather heavily. So what happened was Puppet was still running on the autoscaler server, and when it did its half-hourly run, it decided to restart the autoscaler daemons. And they were still pointing at the old cluster, and they saw all of the servers that had migrated to the new cluster as being unhealthy and terminated them. Very helpful. Thanks, autoscaler. So what could we do about that? Well, just wait a minute. The autoscaler will bring a bunch of whole new servers up. That was relatively easy, except that the cache servers were also being done in the same system. And they have state, and the new ones that come up don't have that state. So what this meant was that suddenly all of the production traffic that was happening was hammering our Postgres replicas, which couldn't handle that because they were not used to that many caches being gone at the same time. It's pretty reasonable. So what we learned from that was that things that do destructive actions like terminating servers should have a lot of sanity checks in them. Hey, am I terminating a large percentage of the servers? I probably shouldn't do that. We needed to improve our process about the migration itself. In just having a peer-reviewed checklist where we made sure that we had extra layers of defense there would have been really helpful. And the other important thing is that stateful services are pretty different from stateless services, and you should treat them differently. So using the same autoscaler technology for that was probably not the best idea. The next-gen autoscaler that we're building has learned a lot from this stuff. It has a bunch of tooling in it to automatically recognize that it's affecting a larger number of servers than it really should and stop itself. And it does it uses our service discovery system to determine health instead of just an agent on the boxes. So we actually get a little more fine-grained detail, like is the actual service okay, not just the host. But yeah, it'll refuse to take action on large numbers of servers at once. Cool. So in summary, observability is key here. People make mistakes. Use multiple layers of safeguards. Like if we'd turned off the autoscaler and put an exit print at the exit command at the top of the script, nothing would have happened if Puppet brought it back up. Little extra things where no one failure can cause you issues. And it's really important to make sure that your system is simple and easy to understand. Cool, thank you. So this is just the beginning for us. We're building a ton of stuff and hiring. And also on Thursday, the entire InfraOps team, many of whom are right there, are going to be doing an AMA in our sysadmin if anybody would like to ask some questions.